Hi, I'm Syed on Maths Online. Today we'll be discussing about the solution of second order ordinary differential equation by the method of variation of parameters. In this method we'll try to solve the second order ordinary differential equation and try to find out the complementary function. Suppose you have the second order differential equation in the form of y double dash plus a times of y dash plus a2 times of y is equals to 5 of x, where this a1 and a2 may be the functions of x or can be constants. Then the complementary function for this differential equation, if it is of the form say c1 y1 plus c2 y2, then the solution of the differential equation can be expressed as y is equals to, we replace the value of c1 by a, keeping this y1 as it is, plus we replace the value of c2 by b, retaining y2 as it is. So this represents the complete solution of the second order ordinary differential equation. Now this a and b are unknown values. We need to evaluate these values of a and b. So where you can evaluate this value of a by using this formula. It is minus integral of y2 5 of x divided by w, where w represents the Wronskian, dx plus some constant k1. Then the value of b can be evaluated as integral of y1 5 of x divided by w times of dx plus k2. The Wronskian is written as y1 y2 dash minus y2 y1 dash, and this is called as Wronskian. Is called Wronskian. Once we get the values of a and b, you can just plug in these values back over here to get the required solution. So let us try to take few example and understand this method of variation of parameters. Solve d square y by dx square plus y is equals to tan of x by the method of variation of parameters. So let us write down this differential equation in the form of the operator capital D. So this can be written in the form of d square plus 1 times of, if I take y common outside, that will be equals to tan of x. The auxiliary equation over here is m square plus 1 is equals to 0. You can find out the roots of this equation by using the calc, or you can factorize it. Go for mode, choose the equations. It's a second order differential equation, option number 3. The coefficient of m square is 1. M coefficient is not there, therefore we'll take it as 0. Then the constant term is 1. The roots are plus I and minus of I. Therefore the roots are plus or minus I. Therefore the complementary function will be, because it is a complex roots, you have the complementary function as c1 cos of x plus c2 sin of x. Now if you want to use the method of variation of parameter, you have to write down the solution by replacing the value of C1 by A and C2 by B. So let the solution be. Let the solution be y is equals to. So replace this value of C1 by A, and this cos of x will remain as it is, plus C2 is being replaced by B. This sin of x will be as it is. So now I need to evaluate this value of A and B. General form that you write for y will be y is equals to, it is A times of y1 plus B times of y2. So here your value of y1 is nothing but cos of x, your value of y2 is nothing but sin of x. So here you have the value of y1 to be cos of x, value of y2 will be nothing but sin of x. So we'll try to differentiate this value of y1 and y2. So if you try to differentiate, y1 dash will be, differentiation of cos of x will be nothing but minus sin of x. Differentiation of this y2 dash is equals to, differentiation of sin of x will be cos of x. So to find out this value of A, we should know what is Wronskian, W. So the formula for W is nothing but y1 y2 dash minus y2 y1 dash. It's just a cross multiplication. y1 y2 dash minus y2 y1 dash. So if you just cross multiply this value, you will be getting W. So this is nothing but y1 value is cos of x into y2 dash is cos of x minus, here y2 value is sin of x into minus sin of x. So it will be nothing but cos x into cos x will be cos square of x, minus of minus will be plus, sin x into sin x will be sin square of x. But we know cos square of x plus sin square of x is nothing but 1. So we have got the value of W to be equals to 1. Now we'll try to find out the values of A and B. So the value of A will be nothing but minus integral of y2 into 5 of x divided by W times of dx plus the constant k1. W value is known. We have the value of 5 of x, that is the right hand side of the question. So right hand side value is nothing but tan of x. You can see the equation, right hand side of the equation is tan of x. Therefore the value of 5 of x will be nothing but tan of x. So if I just plug in over here, the value of A will be nothing but minus integral of y2 value is how much? So you can see that the value of y2 is sin of x. So sin of x into 5 of x is nothing but tan of x divided by the value of W is 1 into dx plus the constant k1. So this will be nothing but minus integral of sin of x as it is. I'll write down tan x to be equals to sin x by cos of x into dx plus the constant k1. This will be nothing but minus integral of sin x into sin x is nothing but sin square of x divided by cos of x into dx plus k1. This will be nothing but minus of integral of, you can write down the value of sin square of x to be 1 minus cos square of x whole divided by cos of x into dx. So both the numerator and denominator are in terms of cos plus this k1. It will be nothing but minus integral of, you can just divide each of the term by cos of x. So 1 by cos of x will be getting. So 1 by cos of x will be nothing but secant of x, secant x into dx. Again apply this integral to cos square of x. So if I multiply this minus with this minus, it becomes plus. Integral of, you will get cos square of x divided by this cos of x into dx plus this constant k1. So this will be nothing but minus. We know the integral of secant of x, log of secant of x plus tan of x, plus here one cos will cancel out. You'll just be left out with integral of cos of x into dx plus this constant k1. This will be nothing but minus log of secant of x plus tan of x as it is. Then integral of cos of x will be nothing but sine of x plus the constant k1. So therefore the value of a will be nothing but, you can first write down the positive value then the negative value. Here the positive value is sine of x, so I will be writing sine x, and this is minus log of secant of x plus tan of x. So you got the first value, the value of a plus k1. So you have got the first value, the value of a. Now we need to evaluate the value of b. The value of b is integral of y1 phi of x divided by w times of dx plus k2. So this is nothing but integral of, the value of y1 is nothing but cos of x into phi of x is tan of x divided by w is 1 into dx plus the constant k2. So this can be further written as cos of x as it is. Tan x can be written as sine of x divided by cos of x into dx plus the constant k2 as it is. So you can see this cos of x and cos of x will cancel out. You will be left out with integral of sine of x into dx plus k2. And integral of sine of x is nothing but minus cos of x plus the constant k2. So you got the value of b to be minus cos of x plus k2. Now these values of a and b we will try to plug in back in the value of y. So you have to substitute it back over here in this given equation. Y is equals to a cos x plus b sin x. We'll take this as equation number 1. So you have to plug in the values of a and b back in this given equation. So we have, therefore, equation number 1 implies y is equals to, so the value of a that we have got is sine of x minus log of secant x plus tan of x plus k1. It is a times of cos of x. Then you have plus b. B value is this minus cos of x plus k2. B times of sine of x. Further, if you try to simplify, I will try to multiply this k1 with cos x. I will be getting k1 cos of x. Then you multiply this k2 with sine of x plus k2 sine of x. Now you can write down the remaining terms that you have over here. So this sine x is being multiplied by cos of x. So you will be getting plus sine x into cos of x. Again multiply this cos x with this log value. So with a negative sign, minus cos of x into, it is log of secant of x plus tan of x. And further you are left out with this minus cos x into sin x, which will be minus sine of x into cos of x. So we can see that this plus sin x cos x will cancel out with this minus sin x cos x. So you are left out with y is equals to, it is k1 times of cos of x plus k2 times of sin of x, then minus of cos of x into log of secant of x plus tan of x. That is the required solution.